This will be for the con exercise, interpret change in exponential models. So just some notes real quick. We're going to be using the exponential equation, and that is going to be y equals a times b to the power of x. Okay, and when x equals 0, okay, we'll just say at x equals 0, we have y equals a times b to the power of 0 in place of the x. And we know anything to the power of 0 equals 1. So at x equals 0, y equals a. So in that case, a is considered the initial value. All right. And as you know from the graph, at x equals 0, okay, x equals 0 would be the entire y-axis. So y equals a is actually the y-intercept. All right, I'll just abbreviate INT. But this right here is actually the y-intercept. And the only other thing you need to know for the b value notice that there's an exponent here. So a will, when you plug in the exponent, a will be multiplied by the value of b over and over again. So basically, if b is less than 1, the function is decreasing. Okay, and if b is greater than 1, the function is increasing. All right, if you take a number a and multiply it over and over again by a value less than 1, it's just going to get smaller and smaller. If you take a value a and multiply it by a number greater than 1, it's going to keep increasing or get larger and larger. Okay, it says Akiba started studying how the number of branches on his tree changes over time. The relationship between the time t in years since he started studying his tree and the total number of branches, n of t, is modeled by this function. Complete the following sentence about the yearly percent change in the number of branches. All right. So this is the initial value. We don't really need to know that for this one, but it's getting multiplied by 1.75 every time the year increases. See, the year is represented by the letter T. So each time you add a number to T, you're multiplying this by 1.75 over and over again. And they want to know the percent change. Okay, we know that 1.75, if you move the decimal over 2 places, is going to be 175%. So this basically, in order to find the percent change, we're going to have to subtract this from 100%. All right, so if you just take 175 and subtract 100%, that is going to be 75%. So it says every year, blank percent of branches, and it's going to be 75%. And we have to select added to or subtracted from. Well, since this number is greater than 1, it's going to be added to. So that's it right there. The reason we subtract 100% is because we already start with 100% of that item. Okay, if you take 100% of something, it doesn't change. But if you take 175% of that thing, you have to subtract it from 100% to see how much it increased by. Okay, Pavlo invested money in a bank account. The relationship between the elapsed time t and months since he invested the money and the total amount of money in the account m of t in dollars is modeled by this function here. Complete the sentence about the monthly rate change and the amount of money in the account. All right, t is the number of months, so it gets multiplied by this amount every time a month goes by, since t is the number of months. All right, so since this number, like we said at the beginning, these are in the form of y equals a to the power of a times b to the power of b to the x. A times b to the power of x. So if the number b is greater than 1, the function is going to be growing or increasing. All right, so it's increasing or grows. And we don't have to do the percentage this time because it says factor of. That just means the multiple that it's being multiplied by each time. So it increases by a factor of 1.01. Alina is an ecologist who studies the change in bear population, the relationship between the time t and years she began studying and the total number of bears n of t is modeled by this function. Complete the sentence about the percent change, yearly change of the bear population. Okay. So this is in the form of y equals a times b to the power of x. Okay, so since the number b is less than 1, the initial value is going to get smaller and smaller every time we increment the year, the value for t. All right, so this is definitely going to be subtracted from because it's decreasing. Now we want to find out by what percentage it's decreasing. Okay, so you start with, well, let's see, 0.67. If you convert that to percentage, just move the decimal over 2 places, and that is 67%. Okay, so you start with 100% of something. And you multiply it by, you take 67% of that thing. So we're losing 100 minus 67%, and that is going to be 33%. Okay, so if you take 67% of something, it is decreasing, or you are losing 33% each time. Okay, Takumi started studying how the number of branches on his tree changes, the relationship time t and years. Since he started studying, the total number of branches n of t is modeled by this function. Complete the sentence about the yearly change. All right, t is the time in years. So each time you increase the year, the initial value gets multiplied by 2. All right, so this is y equals a times b to the power of x. Okay, since the value of b is greater than 1, it's going to be growing or increasing each time. All right, and now in this case, we don't have to do the percentage. It is just by a factor of. So the factor is how much it's being multiplied by each time. It's being multiplied by 2, right? If the exponent here were a 3, let's say the exponent were a 3, that would be 63, and then you'd multiply by 2 3 times. So each time it's growing by a factor of 2, or a multiple of 2.